Dear students, good morning. Today we are going to discuss few topics: free fall, acceleration due to gravity, calculation of acceleration due to gravity, or relationship between small g and capital G. Small g means acceleration due to gravity and capital G means gravitational constant. And third one is value of acceleration due to gravity and variation in G. So first of all, try to understand what is the meaning of freely falling bodies. The falling of a body from a height towards the earth under the gravitational force of earth is called freely falling bodies. So the falling of a body from a height. For example, this is a chalk. I am not applying any type of force on this chalk. This is a freely falling body and this is going towards the center of the earth without applying any force. So we can say this is a freely falling body and the velocity is increasing. If it is going towards, it means velocity is increasing. If velocity is increasing, it means acceleration is produced. So what do you mean by freely falling bodies? The falling of a body from a height towards the earth under the gravitational force is known as freely falling body. Now come to second thing. Second define is acceleration due to gravity. Very clear from the name कि acceleration produced in a body due to gravity. So with the help of this topic, you can define yourself what is acceleration due to gravity. The acceleration produced in a body. The acceleration produced in a body due to gravitational pull of the earth is known as acceleration due to gravity. Same example, this chalk is going towards the earth. Acceleration is producing. So acceleration is producing. Why acceleration is producing? Due to the gravitational pull of the earth. And this is known as acceleration due to gravity. Now come to third thing, that is the derivation. Calculation of acceleration due to gravity, that is small g, or relationship between g, small g and capital G. As I said before, small g means acceleration due to gravity and capital G means gravitational constant. And for this, consider this is the earth. Mass of the earth, let it be m, and the radius of the earth, let it be capital R, and there is a body, small body, whose mass is, let it be small m, and the distance between this body and the earth is, let it be small r. So according to Newton's law of gravitation, this is the earth. Suppose this is a chalk. This is lying. This chalk is lying just above the surface of earth. And the distance between the earth, from the center of the earth to this chalk is r. One body is this chalk and the second body is our earth. If there are two bodies, as I said before, according to Newton's law of gravitation, every body in this universe attract each other with a force. So there is a force of attraction between this body and this body. That is this body and between the earth. And you know, the force of attraction between that two bodies, it is directly proportional to product of their masses and inversely proportional to square of distance between them. So F is equal to G, ये आपने last time discuss किया था, F G M1 M2 upon R square. G means gravitational constant, M1 means mass of first body. First body is, let it be earth, the mass of this body is m, and the mass of second body is small m, and the distance between them is small m. So R square, R square. So the force of attraction between this body and this body is G m1 m2 upon r square. m1 means mass of Earth, m2 means mass of this small body which is lying just above the surface of Earth. According to Newton's second law of motion, F is equal to ma. And for freely falling body, this acceleration is produced only because of gravity. So I am taking G, then that of A. So F is equal to mg. And from equation number 1 and equation number 2, from 1 and 2, left sides are equal, it means right sides are also equal, and G is equal to G mm upon r square. Mm cancel out, so the value of acceleration due to gravity, G, small g is equal to capital G m upon r square. So this is a relationship between small g and capital G. That is, acceleration due to gravity is equal to Gm upon r square. It means acceleration due to gravity does not depend upon the mass of body. Mm cancel out, there is not a mass of body. It means acceleration due to gravity does not depend upon the mass of body. Now, how you can calculate the value of acceleration due to gravity? The value of g, you know, mass of the Earth, you know, radius of the Earth, you know very well. So, capital G, the value of G is 6.67 into 10 raised to power minus 11 Newton meter square per kilogram square. And the mass of the Earth is 6 into 10 raised to power 24 kilograms. And radius of Earth is 6.4 into 10 raised to power 6 meter. Put all these values in this equation, then you will get the value of acceleration due to gravity is equal to 9.8 meter per second square. तो आपको क्वेश्चन कैसे आ सकता है? या तो क्वेश्चन 1 मार्क में आ जाएगा, डिफाइन फ्री फॉल, देन यू कैन डिफाइन दिस फ्री फॉल. डिफाइन एक्सेलरेशन ड्यू टू ग्रेविटी, तो एक्सेलरेशन ड्यू टू ग्रेविटी. कई बार क्वेश्चन आता है 3 मार्क्स में, डिफाइन एक्सेलरेशन ड्यू टू ग्रेविटी एंड एस्टेब्लिश अ रिलेशनशिप बिटवीन स्मॉल जी एंड कैपिटल जी. देन यू हैव टू राइट डाउन ऑल दीज थिंग्स. दिस इज अ सिंपल डेरिवेशन. And there is one more small topic, that is variation in G. You know, our Earth is not exactly round. It is in the shape of, it is in oval shape, elliptical shape, not exactly round. So the value of acceleration due to gravity is maximum near poles, and near equator the value of G is minimum, and at the center of the Earth the value of G is equal to 0. Now question arises, why the value of G is maximum near poles? Look at this. This is a very, very important relationship. The relationship between small g and distance is inversely proportional. If distance is less, acceleration due to gravity will be more, and vice versa. Here, you know, this distance is small than that of this distance, because Earth is flattened here. So this distance is small than that of this distance. If this distance is small, then acceleration due to gravity will be more. But this distance is more than that of this distance. If this distance is more, then acceleration due to gravity will be minimum near equators. But at the center, the value of acceleration due to gravity is 0. But look at this. Suppose body is lying here, then distance is this one. Suppose अगर आप एक टनल बना देते हो यहाँ अर्थ में, नॉर्थ पोल टू साउथ पोल, तो ये एक स्टोन है, सपोज करो स्टोन यहां आ गया, तो डिस्टेंस और कम होगी. सपोज करो स्टोन यहां आता है, तो डिस्टेंस और कम होगी. When you are approaching towards the center of Earth, distance is decreasing continuously. If distance is decreasing continuously towards the center of the Earth, then the value of G would be maximum. But here the value of G is 0. Why so? Remember, actually this equation, this formula is not applicable inside the Earth. This is applicable only on the surface of Earth. Okay, thank you.